Good afternoon and welcome back to Common Core Algebra II with me, Mrs. Teets. It's 5.4 Arithmetic Series. Now we talked a little bit about sigma notation in our last lesson, and today what we're going to do is talk about a series, which is basically the sum of the terms of a sequence. So think about what we talked about in lessons 5.1 and 5.2 when we had sequences. Now what we're going to basically be doing is just adding those sequences together. Okay, so look in the green box here, and it says if the set A1, A2, A3, which is the first, second, third term of a sequence, all right, dot, dot, dot means it goes on forever, represents the elements of the sequence, then the series S sub n is defined by S sub n is equal to the sum as the index goes from 1 to n of A sub I. So let's talk a little bit about what that means in English. So you've already done this already. You've done this before, so this is nothing that's completely new to you. But again, half the problem here is just making sense of it. So given an arithmetic sequence defined by, remember, when I annotate, you should be annotating because I want you to get used to making sure you are picking out the important pieces of the problem. All right, so then we want to find this mess right here. And it does. It kind of looks like you're speaking Martian here. So what I'm going to do first is I'm going to start with this piece right here and try to figure out what this means. So this means, so S5 means I've got 5 terms of my sum. And what this means as the index goes from 1 to 5, I want to know what A1 is, plus A2, plus A3, plus A4, plus A5. So there are the 5 terms of my series. But now I need to go up to this piece up here that's given to us, this piece and this piece, to actually determine what these terms are. So we are given that A sub 1 is negative 2. And making sense of this, we know that A sub 2 is equal to, remember what this means, this is the term I'm looking for, and this is equal to the previous term plus 5. Always making sense of it makes your life so much easier. So A sub 2 is going to be that previous term, negative 2, and then add 5. So this is going to be positive 3. A sub 3 is going to be the previous term, which is 3, plus 5, which is 8. A sub 4 is equal to the previous term, plus 5, which is 13. And A sub 5 is equal to the previous term, plus 5, which is 18. So now we have our numbers. So now we can go back up here and say, well, what's my series going to be? A1 is negative 2 plus 3 plus 8 plus 13 plus 18, which is equal to 40. Basically, just adding them all up, right? I don't think we need to spend time reviewing the calculator portion of this. All right, so the correct answer here would be 2. I wish I could say any questions, but I can't. So if you need to just pause this and take a look at it and kind of look at it one more time, feel free to before moving on to exercise 2. All right, so the terms associated with an arithmetic sequence and the arithmetic series, all right, have interesting properties. Many applications and values that can be predicted with what is commonly known as rainbow addition. Now, this is something we don't see very often, but we do see it once in a while. And you just need a little common sense here. So exercise 2 says consider the arithmetic sequence. Really important here because we know we're not dealing with geometric. And it says, and it's going to be defined recursively by this formula. The series based on the first 8 terms of the sequence is shown below. Terms have been paired off as shown. So what does each of the paired off sums equal? Well, what I mean by that is what is 3 plus 17? What is 5 plus 15? What is 7 plus 13? Well, we can see that they equal 20. Why does it make sense that the sum is constant? Well, can we talk about that a little bit? So the sum is constant because as you move to the right, you add 2. And as you move to the left from 17, you subtract 2. So that's basically what you're talking about, okay? So if you want to write here now, you can say the sum is constant because, notice how I'm using a complete sentence. It is constant because as you move to the right, you add 2, and as you move to the left, you subtract 2. Okay, so moving on to C. How many of these pairs are there? Well, just count the rainbows. 1, 2, 3, 4. Using your answers in part A and C, find the value of the sum using the multiplicative process. Well, I think all they're saying here is that we have 20 and we have it 4 times. So the sum here has to be 80. Now, can we find a way to generalize this? All right, so how many numbers did we start with? 1, 2, 3, 4, 5, 6, 7, 8, 8, right? 4 here, 4 here, 4 here, 4 here. So basically what we did is generalize this now and create a formula for an arithmetic series sum based only on the first term and the last term and the number of terms n. Well, what did we do to find this? We know we multiplied. How did we get 4? Because we had 8 numbers, but we took only 4 loops. So that's going to be represented as, so if we say Sn is equal to n over 2, so in our case it was 8 over 2, which is 4, and then what did we do? How did we get the 20? We added the first term and the last term, and the second to last term, and the second term. So I think, but it says here using only the first term and the last term, so I think what they're getting at here is if you add the first term plus the last term and you multiply it by half of the number of terms that you have, you'll come out with your correct sum. Okay, so remember that because we're going to be using that coming up. All right, so this is basically in this purple box is what we just came up with right here. So which of the following is the sum of the first 100 terms? So there's a couple of other things I need to show here. They said of the first 100 natural numbers, show the process that leads to your choice. So if we want to know the first 100 numbers of a sequence that we know is arithmetic because they're adding 1 to each one, all right, what do we need to know? We need to know what n is. We know n is 100. Do we know the first term? The first term of a natural number? Let's say a sub n is equal to, natural numbers are counting numbers, so it has to be 1. And we know the last term, which is a sub 100, actually is 100. So what do we get? We're using our formula. We say S sub n is equal to n, which is 100, divided by 2, times the first term, which is 1, the last term, which is 100. So this is going to be, you can put the whole thing into your calculator or you could simplify it first. It's 50 times 101, which turns out to be 50, 50. Right here, number 4. Okay, moving on to 4. Find the sum of each arithmetic series described. So we know it's an arithmetic series, kind of important here. Described below, because this is for arithmetic sequences and series that we are talking about. The sum of the 16 terms, so we know 16 terms are given by this. So what do we know? We know that a sub 1 is negative 10. That's our first term right here. We know our last term here, so we know a sub 16 is 50 because it's the 16th term, and n is equal to 16 because it tells us it's 16 terms. So let's use our formula. Sn equals n over 2, a sub 1 plus a sub n. So that's going to be 16 over 2, the first term plus the last term. Do the math, and this one comes out to be 320. I'm not going to spend a long time going over the math. I figure you guys can do that in your calculator pretty easily. Okay, so until you understand this, taking the time to write your formula down is kind of important. All right, if you do that every time, it's kind of that way that you get to remember it. So here they're saying, again, we're still talking about arithmetic series here. The first term is negative 8. The common difference, d, is 6, and there are 20 terms. So what's given to us? We know n is 20. We know the first term is going to be, I'm sorry, I just wrote 20 again. Nope, it's negative 8. What do we need to know? We need to know a sub n, which we don't know. So how can we find that? In the last lesson, we had a great formula that said a sub n is equal to d times n minus 1, right, plus a sub 1. So we're looking for 20 terms. So we know that it's a sub 20 is equal to the common difference is 6. We know n is 20 minus 1 plus a sub 1, which we know is negative 8. So we're looking for this term here, so it equals 6 times 19 minus 8. So this one turns out to be 106. So a sub n is equal to 106. But now we need to go back and figure out what our sum is. So s sub n, I'm infringing on d a little bit here. S sub n, and in this case we can actually write n over 2, a1 plus an. So we're looking for the first 20 terms. 20 over 2. Notice how these numbers kind of correspond. A sub 1, which is negative 8, plus a sub 20, which is 106. And this whole thing turns out to be 980 when we put it in our calculator. Kind of cool, right? All these formulas that you have to know, because this one right here needs to come out of your filing cabinet in your brain. Has no place else to go. It has to be there. Okay, as does this one. Okay, you have to know these. Maybe it might be a good idea if we started a formula sheet for this unit. Moving on to C. The last term is A12. All right, so let's see what this is. So last term, so we need to know A. Remember what we need to know here. The last term, we're finding the sum. So we need to know these 3 pieces of information. So we need to know, we know D is negative 3. Last term is negative 29. So this is a sub 12 is negative 29, common difference, last term. So what do we need? We need to go back to that formula that we had all the way up there, which said a sub n is equal to d times n minus 1 plus a sub 1, right? Because we know that if we're looking for the 12th term, the 12th term is negative 29 is equal to d, which is negative 3 times n minus 1. But we know what n is because we're looking for a sub 1, right? So let's say n is going to be 12 minus 1 plus a1, and that's what we need. We need that first term. So when you solve all this, you get negative 29 is equal to negative 33 plus a1, and a1 turns out to be 4. Again, we're not done with this. You have to make sure we go back and we do our s sub n is equal to n over 2, a1 plus an. So s sub 12 is equal to 12 over 2. The first term is 4. The last term is negative 29. And you put this whole thing in your calculator and you get negative 150. Right? Okay, so D. It says the sum of this series right here. So what do we know? We know a sub 1 is 5. We know a sub n, we don't know what n is. A sub n is 77. We need to know what n is. And again, I think we can go back to using our formula. So our formula says a sub n is equal to d n minus 1 plus a1. Why don't you take a minute and try that on your own and see if you can come up with a sub n. So how are we doing here? We know that 77 is equal to, we don't know what d is. We do know what d is. It tells us here. We had 3. So it's 3 n minus 1 plus a1, which is 5. Once you solve this whole thing, you get n is equal to 25. So now you can go back to your formula and say Sn is equal to n over 2, a sub 1 plus a sub n is equal to 25 divided by 2 times 5 plus 77. This whole thing turns out to be 1025. Yeah, you know something, these can be a lot of work, but if you know the information and you know the formulas that you need and you know how to find the other pieces of information, the rest of it is cake. So write down what you need to. Meet me at exercise 5, which is our last exercise of the video. And it's a word problem. Oh my gosh, we all get crazy with word problems. So, Kirk has set up a college savings account for his son Maxwell. Nothing to even underline there. All right? So he deposits $100 per month in the account, increasing the amount he deposits, so increasing the amount he deposits by $10 per month each month. Then, how much will be in the account after 10 years? It almost sounds like it might be an exponential equation because whenever we talk about money, we always seem to move to exponentials. But if you take a look at this, just take a minute and start figuring out what this means. So the first month he had $100. The second month he increased it and he put in $110. The next month he increased it again and put $120, and so on and so forth. All right? So we need to know how much he has in the account after 10 years. So the first thing we need to know is what that a, because we need to, again, they're asking for the sum. So we know that a sub 1 is 100. We know that our common difference is 10. We know that, do we know what n is? We do not know what n is. Do we know what n is? Yes, we do know what n is. Because if we're saying 10 years, how many, right? So n is equal to 10 years. We know there's 12 months, so n is 120. So we do know what n is. A little common sense once in a while. All right, so what do we need to know? We need to know what a sub n is. So let's go off to the side and figure out our a sub n. A sub n is equal to Who remembers the formula? D times n minus 1 plus a sub 1. So a sub n is equal to d, which we know. N minus 1 was 120, so this will be 119, plus a1, which is 100. Put this whole thing into our calculator, and we get 1290. So this is 1290. This is 1290. And now we can calculate our sum, because we remember that Sn is equal to n over 2 of a1 plus an. In the context that we're talking about, we have S sub n is equal to 120 is equal to n, which is 120, over 2 times the first term, which is 100, plus the last term, which is 1290. So you put this whole thing into your calculator, and you get $83,400. Very cool. Sounds great. I don't know if anybody can afford to constantly be adding $10 a month, though, per month. Lord knows what's going to happen after, 10 years of doing that. So it's not really very realistic. It's just a good example of a series. All right, so that's the end of our video. Tomorrow in class, you're going to be doing your classwork. Hopefully this is going to clear things up a little bit for you. Please come in with questions, because remember that first 10 minutes, I'm really happy to answer any particular questions that you have. Maybe where a number comes from, maybe, something I did a little too quickly. That's your time to ask those questions. Okay, so until then, as always, please make good choices, okay, because we care about you. We want to make sure that you're safe and you're making good decisions. Until next time.